For this question, we're given the reaction, the decomposition of sodium hydrogen carbonate, or sodium bicarbonate, and we're asked what is the heat change when 7 grams of the sodium hydrogen carbonate is decomposed. This is a two-step question. The first, you need to calculate the delta H for the reaction. The second is you need to use the answer from step 1 to answer the actual question. Let's start with calculating the delta H naught for the reaction. We know that the delta H naught of the reaction is equal to the summation of the delta H naught of the products minus the summation of the delta H naught of the reactants. For the products, the delta H naught of the sodium carbonate is minus 1,130.77 kilojoules per mole. For the carbon dioxide, it's minus 393.5 kilojoules per mole. For the water in vapor form, it's minus 241.8 kilojoules per mole. And for the reactant, the sodium hydrogen carbonate has a delta H of minus 950.8 kilojoules per mole. The delta H naught of the reaction is equal to the summation of the delta H naughts of the products minus the summation of the delta H naught of the reactants. And so it sets up to look like this. So then you plug in the values that you have, and now you solve the equation, and you get plus 135.5 kilojoules per mole. Since the delta H of the reaction is positive, this is an endothermic reaction. Now we want to calculate the heat change when 7 grams of sodium hydrogen carbonate is decomposed. The molar mass of sodium hydrogen carbonate is 84 grams per mole. 7 grams divided by 84.00 grams per mole is 0.0833 moles. Set up your stoichiometric ratio. 135.5 kilojoules per mole is to 2 moles of sodium hydrogen carbonate, as X is to 0.0833 moles. When you solve, you get X is positive 5.64 kilojoules. So when 7 grams of sodium hydrogen carbonate is decomposed, the delta H will be positive 5.64 kilojoules.